All right, ladies and gentlemen, I apologize that we did not get an opportunity to meet in person this week for our continuous improvement time, but I did want to provide you with a video resource for you to do your corrections for your 8.5C checkpoint quiz. At the end of the video, if you still have questions, we can meet in person again next week, and I would request that all of you do come in person next week to our continuous improvement time. All right, so let's go ahead and jump right in. So for question number 1, an element has a metallic gray appearance. It has the properties of both a metal and a nonmetal. In which section of the periodic table indicated above would the element most likely be found? So this question's pretty straightforward. It's really just, do you know which section of the periodic table has metalloids? Because it's telling us that, and this is kind of the key phrase, it has properties of both a metal and a nonmetal. So if it's got properties of both, it's going to be a metalloid. And then it's just a matter of knowing where on the table the metalloids are located. Now there's one thing you can use to kind of help remind you. If you go to your periodic table, this little dark stair-step line right here, starting right below boron, and then going kind of stair-stepping down to boron, silicon, arsenic, and so forth. That line is actually the break point, the break line between our nonmetals, which are over here, and our metals, which are over here. And so if you can remember that that stair step is the break point, that's where our metalloids are located, is right along this stair step line. And so when you look at that and then you compare it back to the graphic that you're given, then it becomes obvious that section number 3 is where our nonmetals are located, or excuse me, where our metalloids, not our nonmetals, where our metalloids are located. Section 4 is where our nonmetals are, and section 1 and 2 are actually both metals. All right, number 2. Researcher wants to experiment with an element that reacts like phosphorus but has a greater atomic mass. Which element should the researcher select for the experiment? So there's a couple of things we have to key in on here. First thing, and probably the most important, is this idea of it reacts like phosphorus. All right, so anytime you see the word reacts or reaction when we're talking about elements in the periodic table, you need to be thinking about valence electrons, because how an element reacts is dependent upon its valence electrons. All right, and then the other thing we'll need to key on in just a moment is that it has a greater atomic mass. But let's stay with the valence electrons for now. So if it reacts like phosphorus, it means it has the same number of valence electrons that phosphorus has. So when we find phosphorus here in group 15, Group 15 has 5 valence electrons. Now that's information you have to remember if you're going to be able to answer this correctly. You have to remember that the groups, which are the columns, have the same number of valence electrons, at least for groups 1, 2, and then 13 through 18. All right, so for phosphorus, we have 5 valence electrons. All right, so I need to find another element that also has 5 valence electrons. So we've got nitrogen and arsenic and antimony. But the question also tells me that it has to have a greater atomic mass. All right, and this is where you can get a little bit tripped up because nitrogen is in the same group as phosphorus, so they will react in similar ways. But nitrogen has a smaller mass than phosphorus, which is why arsenic is our correct answer. All right, question number 3. The model of the periodic table below shows the location of 4 elements. The student is asked to identify an element that is pale yellow, brittle, solid, and does not conduct electricity. I really feel like there should be commas in here. The test writers did not write commas. That's not good. At which location in this periodic table would the element most likely be found? All right, so a couple of things here. Since we're talking about properties, and specifically when we see the words brittle and when we see the phrase does not conduct electricity, we know we're talking about the properties of metals, nonmetals, and metalloids. So if we know it's brittle and it does not conduct electricity, then it is a nonmetal. And as we kind of talked about up here in question number 1, our nonmetals here are in section number 4, and if we look at our table, they're over here in the right and upper right part of the table. So the thing that could be tricky on this is that there's 2. There's two answer choices in that particular area, answer choice number 3 and answer choice number 4. And this question actually requires that you know what element number 4 is, that you know that element number 4 is in fact helium. And helium is a gas at room temperature. It's not a solid. So you may not know that number 3, which is sulfur, you may not know that sulfur is yellow and a solid at room temperature. But to answer this question correctly, you would have had to have known that helium is not a solid. And so our correct answer is number 3. All right, question number 4. A student is studying the ways different elements are similar to one another. Diagrams of atoms from 4 different elements are shown below. Which 2 atoms are of elements in the same group in the periodic table? So again, this question requires that you know that groups, similar to this question up here, that you know that groups are organized by the number of valence electrons. So if I look at these different atoms, I need to identify the number of valence electrons for each. And remember, the valence electrons are the number of electrons on the outermost energy level. All right, so for atom number 1, I have 1, 2, 3, 4, 5, 6. For atom number 2, I have 1, 2, 3. For atom number 3, I have 1, 2, 3, 4, 5, 6, 7, 8. And atom number 4, I have 1, 2, 3, 4, 5, 6. So atom number 1 and atom number 4 both have 6 valence electrons, so they are in the same group. Now, if you got confused on that, you could still find this answer. It's just a little bit more complicated. What you would have to do is actually count the total number of electrons for each atom, and then find them on the periodic table, and then see, are they in the same column? Are they in the same group? All right. Now, hopefully you remember that the groups are separated by valence electrons, by numbers of valence electrons, and that won't be a problem. But that's another way you could have solved this. All right, final question. The periodic table is organized into groups and periods of elements. The characteristics of a certain group of elements are listed below. Characteristics of a group of elements: is shiny, is solid at room temperature, has atoms with 2 valence electrons. Which of these elements is in this group? Now, this is a little bit tricky because the fact that it told us that it's shiny would maybe lead us to be thinking more in terms of metals, nonmetals, and metalloids. But in fact, the key piece of information here is that it has atoms with 2 valence electrons. Well, if it has atoms with 2 valence electrons, that means it must be in group number 2, because group number 2 has atoms with 2 valence electrons. So we've got as potential choices beryllium, magnesium, calcium, strontium. And here's strontium here. Now, what we could do is we could look up lithium and aluminum and silicon just to make sure. So lithium, let's find lithium. It's in group number 1, which means it has 1 valence electron. Aluminum is in group number 13, so it has 3 valence electrons. Silicon is in group 14, so it has 4 valence electrons. So our answer choices actually are 1, 2, 3, and 4 when it comes to valence electrons. So, but again, you have to know that the groups are organized by the number of valence electrons, especially when we're talking specifically about groups 1, 2, and then 13 through 18. All right, ladies and gentlemen, if you have any questions that you still need to ask, anything you're still confused on, we can talk about it during our next continuous improvement time, and I look forward to seeing you all then.